In the next 8 minutes, you're going to fully understand how the LEGB rule or scope works in Python. The LEGB rule, or LEGB scope as some people call it, basically consists of 4 different parts. And it effectively tells Python how it should look for variables. So we're going to start from the top. Local is just your innermost scope. So in a second, we'll take a look at this, but it basically just means if you're inside a function, maybe you define a variable inside a function, that variable can only be accessed within that particular scope. That's our first scope called local. But then let's go one level up. Suppose we have this function here, and maybe this function's nested inside of another function. If we then try and access a variable inside this function, and it's not here, what Python will then do, it'll then go to the function it's nested within, aka its enclosing scope. So basically we'll look inside a function. If the variable's not here, it will go to the enclosing function and see if it can find it there instead. A level up from this is our global scope, and that's stuff that will exist at the top level script or module. So effectively, stuff like this. If I had a is equal to 1, all the stuff below a equals 1 can go ahead and use that a. That's my global scope. And then finally we have our built-in scope, and these are the names that are defined by Python. So for example, I can go ahead and do len of something. I've not defined len anywhere, but it is a built-in, so Python has gone ahead and done this, it's imported it, so therefore len is available for me to use. So one more time, we go from local, enclosing, global, and built-in. The best way in my view of understanding this is to go through local, enclosing, and global, starting from the very bottom and working forward. So let's go ahead and try that. Now we'll start off this journey of local, enclosing, global by starting off with a really simple function. Let's go ahead and define a function called inner. You'll see why I've called it inner in just a second. We'll define a variable inside the scope of this function called x and say x is equal to, we'll do inner x just so it's, obvious as to where it's coming from. And then we'll go ahead and print x from within the function. Now suppose I then go ahead and call this function. Let's try and escape it. There we go. And we'll go ahead and do inner. And then we'll go ahead and call our function. There we go. That is our inner x. Now let's go ahead and try something. Notice how running this we get an error saying x is not defined. That's because where this is trying to be printed from, the variable x does not exist within its scope. Okay, it only exists inside the scope of this function. So in this case, this print statement, this x is local to this print statement. It is not local to this print statement here. So that's how our local scope works. Right, we'll clear the screen and then we'll take a look at how enclosing scope works. So the reason I call this inner is because what we're going to do now is do outer. We'll do this here, do it like this, and then we can actually take this inner call. Gotta be really careful of your indentation here and move it there like that. So let's just quickly recap what that's actually doing. The function outer contains a function called inner, and then the outer function is calling inner. So if we hit run now, we should see nothing happen. That's because we need to call the outer function. So if we then go ahead and do outer, let's go ahead and take a look. We should see inner x, and that's fine. So we're calling this. The job of the outer function is to define the inner function. The x is defined locally to the inner function. It prints it, and it's all good to go. So how does enclosing scope work in this case? Well, what we could do is take x, place this guy here, and let's go ahead and do this. If I do outer x, and we'll make a bit of space, and we'll clear it and hit run again. So we get inner x, right? But check this out. If we now get rid of this one, it's fine. We now go to outer x. And that's how enclosing scope works. If we're trying to access something inside a function, and suppose that function's nested inside another function, Python can say, okay, it's not in here. Let's go and check my enclosing scope. So the outer function is actually enclosing the inner function. That's why when we print x here, it doesn't matter that this is commented out. We're going to jump to our enclosing scope, and yeah, we're happy there. Or I can bring this one back, because we're looking at the local scope first. We now go to the inner x, and that's absolutely fine. One level up from that is our global scope. So this is stuff that's defined at our top level. So maybe here I go ahead and do x is equal to global x. It's the big guy. And then what we can do is run this all again and just kind of gradually peel it back. So local scope, right? Let's get rid of this. Okay, we've now gone to the enclosing scope. Let's get rid of our X from our enclosing scope. Python's now going to jump to the global scope, and there you go. So, in my view, the most kind of complicated free levels can be defined as simply as that. X was defined here locally, and that's fine. If it's not here, we'll jump out one level, look at the enclosing scope. There it is. However, it wasn't there in this case. Therefore, Python's going to look in the global scope, and there it is. So, if we remove this guy here, because X isn't a built-in, let's do this here. We get X is not defined, and we'll kind of gradually bring it back. Let's say here it is in the global scope. Cool, that's good. Bring it back for the enclosing scope, outer X. Bring it back for the local scope. And there we go, inner X. What you can do, it's kind of cool, if I do print dir here for a second, check this out. Dir will give you all of the variables or attributes and things which are local to where it's called. So when I print dir here, we can see we have things like name, etc. And there's X, there it is. Let's remove it and do it here instead. Running it this time, we see, there we go, X. So the only thing local to where it's called now is X. So just check out that difference one more time. If we print dir here, perhaps with a line space, because I think that's quite an important difference, to be honest. We'll hit run. There we go. So this one here, because Python kind of comes pre-packaged with lots of different variables already, so we have like the docstring one. We have name, which is the name of the current module, in this case, main.py. However, when it's called inside the scope of this function, X, that's all it has. The only thing available in this current scope is X here. What we could do to kind of show this a bit further is if we do X, Y is equal to this and 1, 2, 3, and then we'll take this and put some line breaks at the end, and maybe we'll do, let's see, we'll do dir here. So these should be different enough, I hope. Let's try that again. So we have 3 calls to dir. That's from our kind of global level, so you can see all the built-in variables that Python's given us. The next dir to run is this guy here, and in this scope we have X and Y available to use, so X and Y appears in the dir output. The last call to dir was inside our most inner function, and this only has X to play with. So there we go, we just get X. Of course, if you remove this guy out, you should see a blank list, because there was nothing available to use in this current scope here. So just to recap one more time, when we're trying to look for a variable, suppose we're inside a function, Python's first going to look inside the function where it's called. If it's not there, we'll go one level up and say, okay, if we're inside a nested function, go and see if it's inside our nested function. Okay, maybe it's not there, time to go one level up. Go and see if it's defined anywhere in the code above this function. That's our global scope. And finally, if we're trying to reference something or look for something, go and look to see if it's a built-in variable. I hope that was helpful, guys, and I'll see you all in the next video. Cheers.